Hi there. What you see here is a National Instruments CDAC 9178 compact DAC chassis with a Serio 9211 module that is made for thermocouples. There are currently 3 J-type thermocouples that are being put into 2 beverages of equal size and proportion, and then a third down here on the heatsink of a USB chiller and warmer. These are J-type thermocouples, so they have a linear curve between -50 to 100 degrees C, which is well in range of what we need to work on. So these 2 glasses I have put hot water in. They start at about 85 to 90 degrees C, and they will soon be at room temperature unless this USB chiller and warmer does its job and keeps the one on the left warmer for a longer period of time. You know, I got this as a gift for Christmas, but I'm not convinced it's actually working because I still have to make trips to the microwave to heat up my tea or coffee. So what I've done is set this up and then written a program in LabVIEW, and over here you can see that there is a chart with 3 trends. You have the green line, which is the beverage temperature without the warmer, so the glass on the right. Then you have the white line, which is the beverage temperature with the warmer, and they are tracking each other fairly closely at the moment, but this has been running for only about 15 minutes. And then you have the USB warmer surface temperature, which is the heatsink, and that's the red line. And at the bottom you can see the minimum beverage temperature, degrees C. So this is very much a personal preference, but I don't like to have anything less than about 35 degrees C because it becomes too close to ambient temperature for me, and then I have to go back and microwave it again. So you can set that for wherever you'd like, but for now and the purpose of testing, I would say 35 degrees C. It'll cut the program off and report the data. And the lower right hand corner is just your stop and start button. So let's see what happens here and find out exactly if the steady state temperature of the beverage on the warmer is actually going to be higher than the other. Something else to note here that I've seen from the very beginning is as soon as I put the beverage on the warmer, the surface temperature of the heatsink actually went up. So there was temperature dissipation from the beverage into the heatsink, and you can see that in the lower left hand corner of the graph. So it's gone up till about 35 and it's just sat there. So let's see what happens within the next 15 or 20 minutes. Well, everyone, it appears my hypothesis is true. The beverage on the warmer is not staying warm longer than the beverage without the warmer. As you can see, they actually converge on one another. Now, the theory of heat transfer, the part that says temperature difference, the greater the temperature difference, the faster the transfer, was holding true. However, the surface area of the heatsink on the cup is not great enough to impact what's happening in the water within the cup. It's just not doing it. There's not enough power coming from this USB connection to the side of my laptop to generate enough heat on the heatsink to make a difference. So, you know, although it was a novel idea, in practice this USB warmer does not work. It's just not getting hot enough. So I would not recommend this, but although the idea was great and I love the gift, it's just not going to do it for keeping my beverage warm. We'll have to get back on the wheel of inventions here and get something going.